Okay, good afternoon to everyone. My name is Nick. I'm the head of business development at xyzt.ai, and I will be the moderator today. Thank you for taking the time to join our first webinar with our partner Xouba. The webinar is entitled No-Code Traffic and Road Safety Analysis Using Floating Vehicle Data. First of all, I would like to introduce you to our speakers. So the first one is Miguel Munoz. Miguel is the head of data at Xouba. Since the beginning of his career, he started in road safety projects, and from there, he began to learn about data in order to improve road safety from a more scientific point of view. Miguel is a civil engineer at the Political University of Madrid and holds a Master of Science of Civil Engineering and Data Science Machine Learning at UI University. Second is Bart Adams. Bart is the founder and the CTO of xyzt.ai. He held senior leadership positions at Luciat and Hexagon. And Bart also holds a PhD computer science from KU Leuven and a postdoc from Stanford University. Shortly, I will go through the agenda, but before we'll start with a few points to mention. So for some interactivity, we will ask you some questions during the webinar. Feel free to answer them. If you have any thoughts or questions, you can always ask them via the chat or the Q&A. We will try, of course, to answer as much as possible at the end of the webinar. Otherwise, we will reply to your questions via email. The webinar is also recorded and will be shared with you as soon as possible after the event. And last but not least, please also mute yourself during the webinar. We can always have a discussion afterwards. So I will take you through the agenda of today. So first of all, we will talk about floating vehicle data and how it opens the door to new business cases. Afterwards, my colleague Bart will explain how you can perform analytics without coding a single line using the xyzt.ai platform. Third, Miguel will talk about how Xouba started and what makes them different. And we will end the webinar with some use cases and a Q&A session. So for those who already were in webinars from XYZ before, we always like to start with a quote. So in this case, it's a quote of McKinsey. By 2030, 95% of the new vehicles will be connected. It will be approximately 2 billion of cars, which actually means that within a couple of years, 1.9 billion cars will be connected. The fact that they are connected means that they send data, floating car data. And what is floating car data for the ones who don't know yet? So actually, all the connected cars, they send out information continuously. Like they send out the location, they send out a certain time, but they also send out speed and acceleration, and even which vehicle type or which fuel type. So we have new business cases that can benefit from floating car data in very different verticals. So first one is mobility. You have one in retail, insurance, finance and investments. For example, road safety. So the car often also sends out parameters such as vertical acceleration or harsh braking. And this can help us get a better view on the quality of the roads and where to perform works. In retail and logistics, you could think about visitor profiling. This actually gives us an idea of where people come from and where they go to. We call it OD matrix. OD stands for origin destination. And if we combine this with other data, we can even define how people get somewhere. Are they using their car? Are they using public transport, shared mobility, and so on? Third one is we also have data on acceleration, harsh braking, and cornering, and this can be very beneficial for insurance companies. So you could think of it as they would be able to give everybody a score based on their behavior on the road and adapt the pricing accordingly. And then the fourth example that I would like to mention today is about electrification and charging infrastructure. With floating car data, those companies will get a better view on how people drive, and this will allow them to better estimate where to install the charging infrastructure. Now, I would invite you to our first poll question of today. What data sources are you using right now? A, open data, B, traffic counting data, C, floating vehicle data, D, I'm looking for good data, or E, other. Everybody can vote now. Let's wait for a couple of seconds to give everybody the chance to reply. Okay. Show the results. So most of you are using traffic counting data or floating car data. And then some of you are also looking for good data or use the open data. Thank you very much for answering this first poll question. I will now hand over to my colleague Bart, who will explain a bit more how the xyzt.ai platform works. Bart?
Okay, thank you, Nick. And thank you all for joining us today. We're, by the way, really excited because we are in Spain together with the Xouba people. And floating vehicle data is definitely also exciting, and it's really changing the way that people do traffic and mobility analysis. But there's also a big problem or a big challenge. The data is not so easy to work with, basically because it's on the one hand very big. It's not just spatial data, like the locations of the vehicles, it's also temporal data, and then there's also all those different properties associated with the points. And so what we saw happening over the past years is that the data is finding its way into those new business cases, but the people that have to work with the data, they become sort of a bottleneck. And that's what we call the data scientist bottleneck. And the reason is basically that you only have a few skilled people typically in an organization or a company that can work with this type of data, if at all, if you have them. So there is really a need for an easy tool. And that's what we brought to market a couple of years ago with xyzt.ai. So we brought to market a scalable self-service analytics tool that is specifically tailored to floating vehicle data. It's scalable, and scalable is really a must because the data easily gets big. It easily gets into the hundreds of millions of data points, if not billions. And if you don't have a tool to work with that amount of data, you will have to slice the data and extract subsets of the data. And that is already by itself a time-consuming task. Second, it needs to be self-service. What we've seen is to avoid the data scientist bottleneck, you have to empower the data analysts. So you have to give the data into the hands of the analysts, but on the other hand, the analysts, they cannot code into Python. So they have to work with a self-service tool. Third topic that we put a lot of emphasis on is on the spatial temporal. If you look at GIS, geospatial systems, they are very good at working with spatial, but they lack the capabilities to work with temporal data. And then if you look at time series tools, they don't work very well with spatial data, on the other hand. They can work with time series data, but not with data that moves. And so we really tried to solve the when, the where, and also the what. And then the final topic is that we saw that there are many closed tools on the market that allow you to look at, for example, traffic congestion or travel times, but they don't allow you to bring your own data. And that's what we also did. So we opened the platform to allow you to bring your own polygons, to bring your own data into the platform to basically put the floating car data in context, but also to use your data sources to do the analysis. And that's what we're going to show today. And on the right side, you see what our goal is. Our goal is really to empower analysts in companies, in organizations, in government institutions to really do the analysis themselves. So what does the tool look like? On these screenshots, you see one of the pages in the tool, and I'll be giving a very short demo shortly. And you can see it's very map-centric. And the fact that it's map-centric helps you in finding what you're looking for. On the other hand, you also see a timeline at the bottom, and time is really a core dimension in the platform. It's always there, and it's always there to be used. Finally, it's multi-layered, so very similar to a GIS tool. You can have multiple layers of data and work with them. And then finally, we also looked at the BI tools of this world, and we saw that we could depict what is going on in the data also with charts and statistics on the data. And I'll show that in a demo. Everything is coupled together. So it's a scalable platform. It's about 1,000 times more scalable than a GIS tool, 1,000,000 times more scalable than a BI tool. And what we also spend a lot of time on is to make it very efficient operationally. So it's very cost effective to use. So I'm going to switch to my browser. Before I'm going to hand over the floor later to Miguel from Xouba, because he's going to show the tool very extensively. So let me get out of my PowerPoint here, and I'm going to switch to my browser. So this is actually the same page that I showed before, and the screenshot before was with INRIX data. This is with Bridgestone data. And this is what the main view of our platform looks like. So you get to see here in the center the map, and you will basically see by default a heat map of where the data is, where traffic is most dense. So it's a density map of where people are driving. It goes from dark blue to white. Here at the bottom, you see a timeline, and the timeline shows you here, you can see it here in this label, it shows you the number of trips over time. So it also gives you an idea of how busy it is over the time period that you're analyzing. Here on the right side, on the right top, you see a layers panel, and that allows you to tweak the styling, the filtering, the layer order, and so on. And then here on the right side, you see what we call the data distribution panels, and they give you statistical insights into the different properties of the data. And when you work with floating vehicle data, typical properties will be the speed of the cars, the vehicle types of the cars, the road type, maybe even what is the speed limit where the cars are driving. So to give you a sense of what is happening, basically we are looking at this region around Madrid, and that's where we are today. And that's basically what we are analyzing. So whenever you see a chart, it corresponds to what you see on the map. So for example, if I would zoom in on a location here, you would see that not only my map updates and refreshes, you will see that also the statistics update. So I would see how many different trips of cars or trucks are passing through this area. I would immediately see what the velocity profile is, how fast do people drive, but also what's the distribution of this velocity. And I would also see how busy it is over time. And this is all coupled. So whenever I, for example, zoom in on my timeline to basically look at a shorter period of time, you will see that the map updates and also the statistics update. And this allows you as an analyst to very quickly find what you're looking for, to basically answer any question on demand. So let me fit again on the timeline and show you, for example, what you can extract out of this data very quickly. So we have floating vehicle data. We have all those attributes like the speed, the heading of cars, and so on. And we have different possibilities to work with this data. And one of the capabilities is to just change the styling of what you see on the map. So for example, now we're plotting a density map of how busy it is, how much traffic there is in those different areas. If I want to look at the velocities, I can just select the velocity property, the speed property here. Choose a color map, which is now by default on this red to blue color map, meaning that red is slow traffic and blue or purple is faster traffic. I can change this mapping. You see the mapping goes from 0 to 80 kilometers an hour, but I can change that mapping if I want. And so now I get to see how fast people drive. And I not only get to see it on the map with the colors, but I also get to see it on the charts here. So for example, if I focus on the velocity, I can see in this region how fast people drive. And of course, you can do a lot more. You can start filtering. You can even start filtering on sub-regions in your data. So for example, if I only want to analyze this road section, I can select this particular area and I get to see what the velocity profile is. And you can even go with floating vehicle data. You can go to road analysis and just focus on a single lane. There's a lot of capabilities in the tool. You can style, you can filter, you can do before-after analysis using split views. You can change your timelines. You can do pure trend analysis, distribution analysis, origin destination analysis, and you can build dashboards and share those dashboards with other people. But I won't take away from Miguel's demo showing all that nice stuff. So it was a very short overview, and after the webinar, we will post a link in the chat also where you can try it yourself into our platform trial. And that brings me, Nick, to the next poll.
Yes, thank you very much, Bart, for this first intro to the xyzt.ai platform. So this indeed brings us to the next poll question. Are you using a self-service analytics solution today? The answers are A, yes, Power BI, B, yes, Tableau, C, no, mostly coding using Python, D, I need a good tool, or E, other. You can now vote. Couple more seconds. We'll show you the results. So here they are. So some of you use Power BI, and then very interesting, of course, some of you need a good tool, and then there is still a lot of people who are actually using Python. So thanks again for answering the second question. And now it is time to hand over to Miguel from Xouba to present his company and what they are doing. So Miguel.
Thank you. Thank you for your help. And well, first of all, I needed a good tool, so that's why I choose your software. For example, here it is. This is what we are. We are Xouba. We're a Spanish startup. We were born or a spin-off of an engineering firm. So we know a lot of road safety and about roads, but this is a game changer data source. For example, in the past, we used to use Excel for counting cars, and we have very small places where we can count them. And right now, with the knowledge of the roads that we have from the past and the future that xyzt is bringing to us, we can make safer roads. That is our biggest theme. As a citizens, all of us, we think that road safety is a must. We cannot negotiate with that. So we create Xouba. What are we doing right now? We are doing 3 lines. One of them is road safety. Like, for example, what type of works are we doing right now in road safety? Before and after studies that we are going to see an example moving forward. Some audits. In Spain, it's mandatory to do some safety audits of the roads, so we can do it with more data. For sure, Vision Zero is not the future, it's the present. We have to be preventive in road safety, and that's the case that we are trying to do. We have to know where the accidents are going to happen, and this is one of our biggest challenges. And also in the working zones, we have some accidents with the workers, and we have to improve their safety. And that's one of our biggest problem right now. Another one is mobility. Right now, the world is high mobility one. For example, our friends are here in Madrid, and tomorrow they will be in another city. So we have to be able to measure that mobility and how is it going. For example, we can measure congestion. Today in Madrid was a rainy day, so we have a lot of congestion. Also, the network performance to our public administration, we have to know how are they doing, and also how we are doing, and origin destination for many cases. Just for example, for any tourism occasion or anything that our clients told us. And also, what we can do is asset management. We can know how the payment is, and we don't have to measure with the standards methods that are currently the standard. Also, we can know which signs are missing, which signs they've put on, and also the signs that are right now in the road. And also what we can do, the incident detection. For example, if a pedestrian is crossing the road, we can do analysis where those places are. So, for example, this is, I think, our first report. It's a Torrelodones one, is in the north of Madrid. What happened here is a lot of schools nearby a roundabout, and it's a very dangerous situation because the cars that are going through the highway are on a really high speed. So the problem came to us. What do we do? Okay, we can measure if you put any traffic calming, we can measure if it's working or not. So let's do it. But you don't have the data of the past. No, we have it because we have it in the cloud. So we use Python at the time, and also xyzt when we had it, and we can compare how that traffic calming measure works. Another one that we are working right now is the Vision 01. We want to prevent the crashes on the cars, and we're making some algorithms, mixing a lot of data sources, and we're trying to show this case next year will be public, and we'll try to make safer roads in every sense. And now we are gonna show some use cases. The first one is a corridor analysis. So let's move on. I have it here. This is a dashboard created for the road administration over there. What was happening? For example, I don't know if you know what's Malaga. Malaga is a big city in the south of Spain, and this problem was in summer. That's logic because there was a lot of traffic. So you can see here is a highway. We can see it with the speed, and here is the city center. Okay, so they ask us, can you measure how much time is people spending in the city? Yes, absolutely. We can measure really easy. I will show you later. Clicking two clicks, you will get this measurement. As Bart showed us, this is, for example, 26th of July of this summer. And when you're moving right away, everything that you've got here is moving. So to create the road safety experts and the guys that are not used to coding or anything like that, we create those type of dashboards. Another question that we can solve, for example, if we're coming to Malaga from this area, which speed are they going? Okay, so it's really easy to show them where people is going and how fast people is going. Also, we have, for example, in this other entrance, the speed distributions. We can see how different they are, and also the travel times of the cars or of the trucks. That's really useful because if, for example, on Monday, it's a lot of traffic, you can measure really easy. I didn't do any math. That's the software. Also, we have events. Like they explained us before, you can have harsh braking, cornering, so you can measure the places where is it an outlier. For example, this roundabout. What happened? Okay, let's measure the speeds in this roundabout in 2 days. Okay, so for example, it's obvious that 26, there was more traffic, and here they were speeding a little bit more than the 27th. So this is a case where we create a dashboard. You can literally click it here and share it to anyone who wants to see it. And that's how life is changing for road safety expert or any political guy or anyone who doesn't know how to code. The next one, for example, this is you are gonna do it with me, an analysis, so I don't have to work tomorrow. What's the problem? For example, this is Girona in the north of Spain, and right now it was a toll road, and now it's a toll-free highway. So there is plenty of traffic, and the people is complaining about how worse is the mobility. Okay, so we have to check if it's true and what is happening. For example, here we have the speed. Okay, but I don't want to show the speed that way. I like that colors, and I want to print red at 60 and blue 120. Okay, so you can see here in the north of Girona, people is in a very high speed, but in the middle, okay, if they're going inside Girona, people is slowing down. Okay, but this is a little messy. What you can do, you can put here your GeoJSON, your zones of interest that we upload. For example, we're gonna see filter here in the area inside my marker number, for example, 53. Okay, so I zoom in, and you can see here it is. Okay, but let me look at that. Yes, some cars going in the other direction are making like a little mess here. Okay, so I will clean it. You can see here in the heading, like the biggest one, let's focus, the biggest one are here, but here there are a little bit that are showing too. Okay, so we're gonna filter by a property that is the heading. Okay, so they have to be above 180. Perfect. So we have only the cars that are going in that way to the south. Perfect. Another question. Okay, but I want to know if the people that is going at that speed is the trucks, the cars. Okay, we're gonna filter by what type of car. For example, I only wanna see heavy trucks. Okay, this looks really different, but I'm not looking. Oh, okay, let me see it that way. In this way, you can compare with two maps. For example, in this, I'm not gonna filter by heavy trucks, how different are. If we're going to the speed, we can look here in the left one that trucks are going at 90, and here at the right one, cars are going at 120. So you can compare really easily how people is going. Also, we have upload events. Let me show events and start measuring it. Okay, so we upload some events. Okay, but this is a mess, Miguel. You're doing wrong. Yes, I am doing wrong, but I'm gonna show you. Event type. Okay, so I have braking, cornering left, cornering right. I'm gonna look for an outlier. For example, wow, that looks like people is cornering right too fast. Okay, so I can choose, like Bart explained me, I can draw a polygon, and I want to know the speed of the people only in that polygon. Okay. So with this created, I'm gonna do Girona area inside the trial one, include. So I can see the speed of the people that is going over there. For example, now I cannot see anything if the speed is so low. Okay, so I'm gonna change my numbers. And there it is. There it is. Let me disappear. I don't know where I am, but I will make it. Here I am. I put this layer off. Okay, so people is going at 40 kilometers. So maybe the road safety expert will have another tool telling how people is going, and maybe this place is prone to have a crash because we have to slow down people going around here. So that's one example that we can make it. So I wanna let my road safety expert this in a dashboard because he doesn't like it to work as much as you've seen that we do. So I will let him the dashboard that you've seen in this one to him. Also, we can make it through the API, uploading everything that he needs and give it to them as he wants. So as you can see, I'm not any expert about nothing, but I can make a really fast analysis with this tool. For my part, that's it. So I will let Bart and Nick continue. So thank you very much.
Thank you very much, Miguel, for this showing our tool. It's very easy to use. So I think the most important question of today, are you interested to find out more? Different answers possible again. A, yes, about the Xouba services. B, yes, about the xyzt.ai tool. C, yes, about both Xouba and xyzt.ai. Or D, not for now, thanks. You can still take your time to vote. I think that everybody more or less voted. So I would like to take you through the key takeaways of today. Before moving over to the Q&A, we have received quite a lot of questions, so we will try to answer as much as possible. So key takeaways of today. I think we can all agree that floating vehicle data is a valuable resource for mobility and road safety analysis. As explained earlier in the webinar, it really opens the door to new business cases or to more easily solve existing ones. Even though we know that coverage is of course not 100%, you have different providers, not all cars are connected. Although it is more than sufficient to do the statistical analysis we do with the xyzt.ai tool. And I think the third key takeaway of today, and probably the most important one, is that both Xouba and xyzt can help you with solving your business cases and accelerate the time to insights from weeks to minutes. And I think it's also very much what Miguel showed us today. So before thanking everybody, I would like to move over to the Q&A. We have received quite some questions, so I will maybe start with the first one. The first one, Bart, is one for you. Do we have in our xyzt.ai tool some capabilities or solutions, products, initiatives in the field of insurance?
Yes, it's a very good question. So insurance is a very important topic, especially because we see that there is a move from people buying cars to people basically leasing or renting cars. So this driver-based profiling is extremely important. So our tool is used for insurance cases, and it is used, as Nick explained, to basically bring insights, for example, into fleet usage, to profile how is the fleet being used, what are the outliers, which cars are the outliers, or which drivers are the outliers. And then some of our users also use it to basically teach or educate people on their driving behavior. So definitely it's possible. It's also very easy to set up dashboards for that. But it is a self-service tool. So you can basically focus yourself on what you want to show and what you don't want to show with the tool. But definitely, if interested, we can go into a more detailed demo maybe on what would be possible for insurance cases.
Okay, perfect. Thank you very much, Bart. Then Miguel, we have received a question from Jan, which I believe you can answer. How do we deal with data preparation? So if there is biased data or if we have outliers, do you plan to use advantage statistical methods like clustering, regression, modeling of drivers, etc.?
Well, first of all, thank you, Jan. We already met, so it's a friend of mine. But the question is not as friendly as it looks. No, but the first problem of the data is how clean is it, and the real problem is how biased. The bias right now, we cannot do anything about that. We have the connected vehicles that we have, so we cannot do it anything. But the bias, it's kind of surpassed because we are comparing, for example, in before and after studies, we are comparing the same model of cars that are the ones that we have the information. So that's recovered. But the advanced statistical methods right now, we are on our way to improve it and to clean properly the data. We do it, or maybe with Python before, with a data scientist that decides to clean it, or also with this tool you can clean it. Some outliers that, for example, it makes no sense that a car is going outside the road, or a car speed is negative, for example. That's an easy cleaning part that anybody can do it. But yeah, we're on our way to know how to clean it properly with our more data preparation before the study.
Okay, thank you very much, Miguel. Other question from Jiri. Bart, I think that's one for you again. Does the platform treat the data as points or as lines?
Okay, good question. You can do both in the platform. So what you've seen, I think most of the examples that we showed, I think Miguel had some with lines, but I think most were with points. Both have their advantages. You can use both. For example, when using points, it's nice that you know that what you're looking at is actually really in the data. So whenever you see a point on the map, you know that it's in the data. When you see a line, sometimes you have points that are maybe far apart, and then that line will be a straight line connecting those points. And then you might be misled by the fact that a car is driving along that line. On the other hand, sometimes the lines can be very useful, for example, to do a replay, to do a flow replay, then you really see the flow and the movement. But the short answer is you can do both.
Okay, Bart, thanks. Then we have another question from Diego. I will maybe answer that one. Is live data possible, and what is the delay of receiving the data? So yes, live data is possible in our platform. You can actually combine historical data with a live data feed and do both at the same time. And then the delay of receiving the data depends obviously on the supplier. So we do have suppliers, we had it lately, who can, depending on where we are, deliver data to us within 3 minutes. So their SLA is 90% of the data delivered within 3 minutes. So I think we can agree that we can consider that as live and a good delay of receiving the data. Then we have another question from David that just came in. It seems that GPS data is out of the road carriageway. Regarding this, is the accuracy of every variable measurable, analyzed, known? I guess it will, David says it will probably depends on the type of vehicle of the manufacturer. I'm looking at both Bart and Miguel. They have most experience with the data. So
yeah, I can say maybe two things about this. As some of you might know, GPS accuracy varies also based on location. For example, if you are in a city and you have this canyon effect, where you're between many high-rise buildings, for example, the accuracy will differ. If you're in a tunnel, the accuracy will differ. So that's one thing to be said. And also in the variables, of course, there's different ways that providers or OEMs compute those statistics. What I do know is, from working with the many data providers that are out there, is that they spend a lot of time themselves also to investigate data quality, data coverage, data variance, before onboarding or signing up a new provider, before fusing the data, and before making the data available. One thing also is that just by looking at the data, it helps you a lot as a data scientist or an analyst to make informed decisions. And I'll give you one example. I once saw a data set, and there was a lot of variation in the location of GPS positions, but there was also a very dense distribution of GPS locations exactly at the center of the road. And that's just by seeing that on a heat map, I would immediately know that this data provider would provide both GPS data points, but also map-matched data points. So data points that are moved onto a basically virtual line in the center of the road. And if you would not see the data, most likely your algorithms would not even know that this is happening. And now you would know that this is happening. So long answer to a difficult question. But in my experience, just looking at data helps you a lot in making good judgment on the accuracy and the distribution of the variance of the data.
Okay, Bart, thanks. There is an other one, and again, I think you both have experience with it. Question from Jochen. Is it possible to add historical data sets to the platform? And he also gives an example, like, for example, accidents, to have analytics of probable unsafe spots. So, for example, in relation to higher speeds, we have more accidents. Again, I guess you both have a lot of experience in this, but maybe Miguel, you can take this one.
Yeah, I mean, for sure you can log in historical data, but in our case, the problem is the volume of the data. For example, we cannot compare 2020 because of COVID and because there was almost any car there. But for example, if I can look for a specific spot, I'm gonna share my screen if you want. Showing right now, I think that it is.
Yes.
For example, this is the entrance of a village in Madrid, in the north of Madrid, where they had speeding between some houses. Okay, so they installed a CVT, a variable speed control. So if you go above 50 kilometers per hour, it's gonna get red, the light. So what happened? It's obvious that people slow down because they don't want to stop. So that's, for example, one case that they told us that is problematic. What can we do in the future or in the present? We can paint those places that are dangerous, and we can look for more outliers with the speeds, looking at the similarity of them.
Okay. Thank you very much, Miguel. We have 2 more questions, and then we will end this webinar. I think one, Bart, it's one for you again. We have seen in one of the poll questions that a lot of people have floating car data or traffic counting data, and I guess in a lot of cases they have both. So can we combine this in the XYZ platform?
Yeah, good question. It relates a bit to the previous question also. So yes, you can combine different data sets, and it doesn't have to be only floating vehicle data. It can be event data indeed, or counting data. And in the platform, we support basically 2 major groups of data. One is what we call movement data, things that move or people that move, like GPS coordinates, like the floating vehicle data. But the second group is what we call geospatial time series data. And there you have locations, like, for example, the locations of traffic counters. And then with every location, there can be a time series or multiple time series associated. And so you can also upload that. And the locations, we accept GeoJSON, which is points, lines, or polygons. And then you have the time series, for example, in CSV files, you can upload them and then refer back to a location and this way. And like we showed, you can, for example, split the screen, and on one side show the floating vehicle data, and on the other side show the traffic counting data. And then you could sort of correlate the absolute numbers that you counted with the percentage of cars that are captured by the floating vehicle data.
Okay, thank you very much, Bart. Last question for today. To whom should we reach out, and how do XYZ and Xouba collaborate? So I can take this one as well. You can reach out to Miguel, to Bart, or to myself. And how do we actually collaborate? So Xouba has a lot of data, or a lot of relations with data providers. We obviously at XYZ have the tool. So it's a very good combination. And then on top of that, also Xouba, in meantime, they have gathered a lot of experience with our tool. So any type of assistance you need in uploading data, in getting your insights, in creating those dashboards, in sharing those with others, I think that Xouba will be more than happy to help out. One small thing still, we have got a lot of comments in the chat about the AP7 and the fact that it was opened. So
I knew it.
Miguel, I think you know your action for tomorrow. So with this being said, I would like to say thank you to everyone who joined us today. I sincerely hope that you found it very interesting. If you still have questions, then please don't hesitate to reach out to one of us. We will also send out, as mentioned before, an email shortly after this webinar with all the links to the recordings. And then last but not least, thank you very much, Bart, and thank you very much, Miguel, for this very interesting webinar. And to all of you as well, thank you very much for attending, and have a nice rest of your day. Bye.
Bye.